Mark your own here. Oh, got my favorite student, good old Anne. It says be sure to report to the correct number of sig figs. I need to remove that. I used to be fussy about sig figs in Physics 11, and then I just kind of went, meh, you know what? I've taught it to you in the first unit, but we're not going to flog it. An object is pulled at a constant, ooh, that's important, by a horizontal 12 Newton force as shown below. So here's what that means. I'm going to do a free body diagram, although since they gave me a picture, Sarah, I'm going to label the picture, which technically isn't a free body diagram because I didn't represent the mass with a dot, but whatever. I'm going to label my forces. I definitely have gravity down, and in this case, normal force up, same size as mg. Friction. How big is friction in newtons exactly? How big must it be? Got to be 12, Newton's first law. So it wants the coefficient of friction. So normally I would go friction equals mu times the normal force, and I would get the mu by itself. How would I get the mu? Sorry, normally I would go winner minus loser and get the mu by itself, but since I know friction, Sarah, at 12, I'm going to go straight to friction equals mu times the normal force. In fact, I'm going to put a 12 right there. How would I get the mu by itself? How will I move the normal force over? So you're telling me mu is going to be 12 divided by the normal force? Problem, I don't know the normal force. Oh, look, I know the force is the same size as the normal force. Which one? Is it A? Doing the math in my head really quickly. So it's going to be 12 divided by bracket 5 times 9.8. Yeah, it's roughly 12 over 50. 0.24, yeah. Is that slippery? A little bit. That would be if you were walking on a floor that had a coefficient of friction between your shoes. And you know what? It would be like walking on linoleum in socks. Can you walk okay in socks just fine? Yeah, but every once in a while, if you're not careful, you suddenly catch yourself slipping a little bit. That's about a 0.24. Okay? You don't need to know that, but I always like to try and tell you what's big and what's small. Air resistance. Okay, free body diagram. I have gravity down. It tells me it's accelerating downwards and that it's falling downwards. If it's falling downwards, air resistance is pointing up. And if it's accelerating downwards, air resistance is smaller. And I had to tell you all those pieces of information, or you would have had to make some assumptions, Rachel. Who's winning? mg. Who's losing? Air resistance. What's that going to equal? ma. As far as I'm concerned, for this question, Braden, I can either give you the acceleration and say get the air resistance by itself, swappy dance, or I can give you the air resistance and say find the acceleration. Here I did the second version, so I'm going to use Shay's theorem. Looks like A is going to be 0.62 times 9.8 minus 1.4 0.62 times 9.8. I have no idea what the answer is here. Do you get 7.54? Oh, there was a built-in error check. I knew the answer had to be less than 9.8 because with no air resistance, that's the maximum I would have. So that at least works. Is it 7.54? So 2 out of 2 if you got that. And it's an acceleration, meters per second squared. And then the usual, if you forgot the units, half mark off. Otherwise, I would probably give you 1 mark for that, half mark for the numbers, and a half mark for the answer. I'm not giving you marks for the free body diagram just because that's, you kind of got to do that to solve it. Although some of you may get good enough that you can kind of visualize the free body diagram in your head and get the equation. Kate and I would never do it that way on a test or a quiz. I might try it that way in my homework if I get lazy. The what force? The net force. The what force? The net force. So F equals ma. So F equals 1200. I need to find what A is. VI is 0 from rest. VF is 15. D is, so it's going to be VF squared minus VI squared all over 2D 0 squared minus 15 squared all over 2 times 85. Good morning. I'm so glad you made it. Yeah. I did it again. I did this last time too, I think. Because it's not slowing down, it's speeding up, Mr. Duke. You're going to get a positive acceleration. 15 squared. Does the minus 0 squared make a difference? I'm not going to type it. Divided by 2 times 85. I got an acceleration of... But you know I'm going to use my answer button. Was it 1200? Yep. Do you get 1588? I'll go 1590. I'll go to 3 sig figs, as is my wont. If you got that, 2 out of 2. Otherwise, I would probably give you a half mark if I saw that, a half mark for finding the acceleration, a half mark if I saw the net force, F equals ma, and then a half mark for the answer. Ooh, 3 marks. Cool. What does number 4 want me to find? What does it really want me to find? Yeah, it's VF, but what am I going to spend most of my time finding initially? I think I'm going to need A. So I started out thinking like this. Hannah, I said, okay, they want me to find VF. They gave me VI is 0. They gave me D equals 16 meters. If I knew the acceleration, I'm good to go. So I'm going to find the acceleration, and then I'm going to use VF squared equals 2AD square root. What happened to the VI squared? 0. Okay. By the way, I could also have given you a VI not at rest. It's just I'm lazy. How am I going to find A? I think this is a good job for a free body diagram. Although, did they give me a picture? I'm going to be lazy and label the picture. mg. Normal force. This is what we decided to call F applied, the mystery force from coming from off the page, and friction. I think we are accelerating, so I think friction is smaller than F applied. If friction is bigger than F applied, I'll find out because I'll get a negative acceleration. And then the answer would be VF will be 0 because it didn't go, well, no, it said it went somewhere, so it's got to be accelerating. Who's winning? Who's losing? What's that going to equal? MA. Shay's theorem. F applied minus mu times the normal force all over m. I don't know the normal force. Oh, but look. I know the force is the same size as the normal force. Which one? So I can do that. So the acceleration is going to be 56 minus 12, no, minus mu, Mr. Duke, don't forget the mu, minus 0.24 times 12 times 9.8 all over 12. Bracket 56 minus 0.24 times 12 times 9.8 divided by 12. Do you get an acceleration of 2.3146 repeating? So I'm going to write 2.31. Now I'm going to walk over here. VF is going to be the square root of 2 times 2.31. I'm going to use my answer button. Times 16. 2 times answer button times 16. That seems way too fast. Oh, square root. I was like, that's crazy fast. 8.6? 8.61? Yeah? Okay. So, if you got that, 3 out of 3. Okay? Otherwise, I would probably give you 1 mark if I saw that. I would give you probably, I think, 1 mark for that. You know what? I got to break up these into half marks. I would give you a half mark for that, a half mark for that, half mark for finding the acceleration, and then a half mark for finding the velocity. Speed. Next page. Yeah, you're right. I should have signed that because that's such a spectacular drawing, Mr. Dewick. There you go. Wants me to find A. Well, let's see. We have gravity, normal force. The skier pushes backwards with the poles, but I think that means the snow is pushing forwards with an applied force, or F snow, or whatever you want it to call it. And there is friction. So I think my equation is going to be F applied minus friction equals MA. Shay's theorem. A is going to be F applied minus mu times the normal force all over M. I don't know the normal force. Oh, but look. F applied minus mu mg all over M. It's going to be 110 minus 0.11 times 47 times 9.8 all over 47. I've got a typo, don't I? Let's try that. 110, not 10. Do you get 1.26? Not a very big acceleration. This would be a bit weird in real life. This is probably cross-country skiing because it's on flat ground. In cross-country skiing, basically, when you give yourself a push, you accelerate, but then as soon as you stop, you start to slow down. This would not be a constant acceleration. It would be speeding up, slowing down, speeding up, slowing down, right? Well, we can't really deal with that, so. Oh, if you got that 3 out of 3, otherwise I would probably go something like this. Let me see, 1, 2, 3, 4, 5. I might do a half mark for that, half mark for that, half mark if I saw that you'd replace the normal force with mg, half mark for the numbers, and then, oh heck, 1 whole mark for the answer. I don't know. Free body diagram. Gravity. Normal force, F applied, which is what they want me to find. How do I know friction is the same size as F applied? Steady speed. So I could, Shay, walk through a whole winner minus loser, but I'm going to say, I think I can safely argue F applied equals friction. F applied equals mu times the normal force. I don't know the normal force. F applied equals mu mg. It's going to be 0.32 times 20 times 9.8. Do you get 62.72, 62.7? People nodding? Here, really this should be probably a 2-mark question, not a 3-mark question, but okay. I would probably give you 1 mark if you realize that. Half mark, half mark, half mark for the numbers, and then a half mark for the answer. Can you give yourself a lovely score, please, out of, count them, 15? Number 1, I guess, was worth 2 marks, even though it was multiple choice. Okay. Any lawyering with me? Now is the time.